All right, guys, we are going to do the Pythagorean Theorem today. This is chapter 9.5, and you will need your calculator for today, so go ahead and take a minute to go get it if you don't have it already, and we'll start the lesson when you get back. Okay, here are the key concepts for today. So go ahead and get these copied in your notes. Pause me as you copy, and then replay me when you're ready for the explanation. Okay, so the Pythagorean theorem, in order to have the Pythagorean theorem, we have to have a right triangle. And remember, a right triangle is denoted by this little box right here, this little red box. And that is the sides that are adjacent to the right angle are called legs, and the side opposite to the right angle is called the hypotenuse. Now, I always like to find the hypotenuse first because that seems easier for me. So I look at this right angle, and the side that is directly across from the hypotenuse, the side directly across from the right angle is the hypotenuse. Okay, so we find the right angle directly across is the hypotenuse. And then the other two sides, this side and this side, are your legs. And these are adjacent right next to your right angle. Okay, so here's the key concept. If a triangle is a right triangle, then the square of the leg of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Blah, blah, blah. Basically, all that means is a squared plus b squared equals c squared. Or leg squared plus leg squared equals hypotenuse squared. And here is your formula right here. C squared equals a squared plus b squared. And this is one that you should know. And that's Pythagorean's theorem. A squared plus b squared equals c squared. All right. So your hypotenuse, remember, is directly across from your right angle. And it's usually denoted by c. Okay, c is usually the hypotenuse. Your legs are a and b. And so it's going to be leg squared plus leg squared equals hypotenuse squared. Okay, and then I have a little bullet down here to determine if a triangle is a right triangle when we're given three sides. Okay, so we're going to plug those three sides into the Pythagorean theorem. If it equals, both the numbers equal, then it is a right triangle. If it does not equal, then it is not a right triangle. And we'll do a couple examples to show you what I mean. Okay, so Pythagorean's theorem, a squared plus b squared equals c squared. Oh, just a note before we get started too. Let's see, I don't really have a whole lot of room, so I'll just do it right here. If we are trying to solve, let's say if we have like x squared equals 25, and we're trying to solve for x, okay, we can't just, add or subtract or anything because we've got this little x squared. Okay, so to get rid of a square, all we need to do is we take the square root. And when we take the square root of a square, that actually just kind of cancels out the square. Okay, when we square root a square, that cancels out everything. So we're just going to say x equals, and the square root of 25 we know is 5. Okay, one more example. So if I have x squared equals 36, I want to take the square root to get rid of this squared. Those cancel out, and I'm left with x equals 6. Okay, just so we, that's something that we're going to use later on in the lesson. Okay. So here are a couple examples. Find the length of the hypotenuse in each right triangle. Round to the nearest tenth if necessary. Okay, so we're going to find the hypotenuse. And remember, hypotenuse is directly across from the right angle. Okay, so my Pythagorean theorem is a squared plus b squared equals c squared. Now, a and b are both the legs. So here's a leg, here's a leg. So I'm going to say 12 squared plus 16 squared equals, and I'm looking for my hypotenuse c, so it's going to say c squared. So 12 squared is 144. 16 squared is 256. C squared is just c squared. 144 plus 256 is 400. And all I'm doing is just trying to solve for c. Okay, now I'm at 400 equals c squared. Now I want to eliminate this squared, so in order to do that I have to take the square root. Okay, when I take the square root, those cancel out and I'm left with c. Now if you type in your calculator the square root of 400, you will find that 20 equals c. So our hypotenuse is C. Our hypotenuse is 20. Okay, here's your turn. I want you to try this one as best you can, and when you're ready for the answer, go ahead and replay me. Okay, so we're looking for the hypotenuse, which is across from the right angle. So we're just going to plug in our other sides as 5 squared plus 9 squared equals C squared. So we have 25 plus 81 equals C squared. 25 plus 81 is 106 equals C squared. And I'm going to take the square root of 106. Cancel out the square root. We got C. The square root of 106 rounded to the nearest tenth is 10.3. And that you just get from simply typing into your calculator. All right. On this one, we don't have a triangle, but we're given all of the sides. And we are looking for one of the legs. Okay, before we were looking for the hypotenuse. Now we're looking for the legs. So we have 9 squared plus, we don't know B squared, equals C squared, which is 41 squared. Remember, our formula is A squared plus B squared equals C squared. So all I did was I plugged each one of those into our formula here. Okay, so then we solve 9 squared is 81 plus B squared equals 41 squared, which is 1,681. And I'm going to try and solve for this B squared here. So I'm going to subtract 81 from both sides, and I have B squared equals 1,600. I take the square root to eliminate that square, and B equals 40. Okay? All right, I want you to try this one where we're missing A. So we're given B and C. Go ahead and try this one best you can, and when you're ready for the answer, go ahead and replay me. Okay, so we have A squared plus B squared equals C squared. Your A is, we don't know, so it's A squared. Your B is 12 squared. Your C is 19 squared. So we solve A squared plus 144 equals 361. We subtract 144. And we have A squared equals 217. We take the square root. We have A equals 14.7, rounded to the nearest tenth. Okay, hopefully you got that one. And we're on to the next example. In this one, it is determine whether this triangle is a right triangle. And remember the very first slide we talked about, if you plug that into the Pythagorean theorem and it equals, then it is a right triangle. If it does not equal, then it's not a right triangle. And I'll show you what I mean by that. Okay, so we've got our Pythagorean theorem as A squared plus B squared equals C squared. Okay, we're plugging it into the Pythagorean theorem. So we've got 5 squared plus 8 squared equals 9 squared. And then we just solve. So 5 squared is 25 plus 64 equals 81. 25 plus 64 is 89 equals 81. Okay, now does everybody see that this does not equal? 89 does not equal 81. So this is no, not a right triangle. Okay, because these do not equal, that means it's not a right triangle. All right, I want you to try this one and see what you can find out. Okay, you're given the sides of a triangle. Determine if it is a right triangle or not. All right, replay me when you're ready for the answer. Okay, so we have A squared plus B squared equals C squared. And we have 16 squared plus 30 squared equals 34 squared. And this is 256 plus 900 equals 1156. And then 256 plus 900 is 1,156, which does equal 1,156. Okay, so because both of these are equal, when they're both equal, what does that mean? That means that they are, yes, it is a right triangle. Okay. Hopefully you got the difference between a right triangle and not a right triangle. Here's your practice problems for today. So go ahead and give these a try and do the best you can, and we'll go over them next time we see them.